What does it take to build a warship powerful enough to fire a shell nearly 24 miles, move a vessel weighing tens of thousands of tons across the ocean, and keep fighting even after taking serious damage? You have to build more than a ship. You have to build a floating weapons system, power plant, command center, machine shop, and city all inside one steel hull. This is USS Missouri, BB-63, the last battleship ever commissioned by the United States Navy. And to understand what made Missouri so powerful, we have to go inside the machine. Start with the hull. Missouri belongs to the Iowa class, a battleship design built around a difficult engineering requirement: combine enormous firepower with enough speed to operate alongside fast carrier forces. The result was a ship more than 880 feet long, with a displacement of tens of thousands of tons and 4 propeller shafts driving the ship through the water. But the hull wasn't simply a giant steel shell. Inside were layers of structure, compartments, machinery spaces, ammunition handling systems, fuel storage, electrical equipment, crew spaces, and damage control systems. The idea was simple. If one section of the ship was damaged, the entire ship couldn't simply stop functioning. That philosophy of compartmentation was one of the most important parts of battleship survivability. Now, go deeper into the ship, and you reach something that most people never see: the power plant. Missouri was powered by 8 oil-fired boilers. Those boilers transformed the chemical energy and fuel into heat, producing high-pressure steam. That steam was then directed toward 4 sets of geared steam turbines. And this is where the system gets interesting. The turbines converted the energy of the steam into rotational motion. Reduction gears then transferred that rotation to 4 enormous propeller shafts. Those shafts turned the propellers, pushing the ship through the water. So the chain was essentially this: fuel becomes heat, heat becomes steam, steam becomes rotation, rotation becomes thrust, and that thrust moves a battleship weighing tens of thousands of tons. But Missouri wasn't built simply to move fast. Its defining feature was sitting on top of the hull: 3 enormous gun turrets. 3 guns in each turret, 9 16-inch guns in total. Each barrel was approximately 68 feet long. And these weren't simply large cannons. They were massive mechanical systems capable of rotating the turret, elevating the guns, loading ammunition, absorbing recoil, and precisely controlling where the guns pointed. Inside the turret, ammunition had to travel from the ship's magazines up through the ammunition handling system and into the gunhouse. The projectile and propellant then had to be positioned for loading. The breech closed, and once the gun fired, thousands of pounds of force were released almost instantly. The barrel accelerated the projectile forward while the gun system had to absorb the enormous recoil moving in the opposite direction. But here's the part that's easy to miss. The guns were only the final step. A battleship still has to know where to aim. That is where the fire control system comes in. Missouri used directors, optical systems, radar, computers, and other fire control equipment to determine how the guns should be aimed. The system had to account for things like range, bearing, the movement of the target, the movement of the ship, and the ballistic behavior of the projectile. In other words, the ship wasn't simply pointing a giant gun at something and pulling a trigger. It was solving a moving 3-dimensional problem, and the solution had to reach the gun crews quickly enough for the weapon to matter. Now look beyond the guns, because a battleship is much more than its main battery. Missouri carried secondary weapons, anti-aircraft defenses, radar systems, communications equipment, navigation systems, and command facilities. Every one of those systems required power, cooling, maintenance, personnel, and space. And that brings us to one of the most fascinating parts of the ship. Missouri was essentially a floating city. Thousands of sailors could live and work aboard her. That meant kitchens, medical facilities, sleeping quarters, freshwater systems, ventilation, electrical generation, food storage, workshops, communications, and an enormous network of pipes, cables, valves, pumps, doors, and machinery. Every one of those systems had to keep working while the ship was at sea. And if something went wrong, Missouri also had to be able to fight the damage itself. Damage control teams could isolate compartments, fight fires, control flooding, repair equipment, and keep critical systems operating. Because survivability wasn't just about how much armor the ship had. It was about what happened after the armor was penetrated. Could the crew contain the damage? Could the ship maintain electrical power? Could it keep propulsion? Could it continue fighting? That is the engineering philosophy behind a warship like Missouri. Thousands of individual systems are connected together, but the ship has to remain functional when some of those systems fail. And Missouri wasn't only impressive mechanically. Her history made her one of the most recognizable warships in American history. Commissioned in 1944, she entered service during the final stages of World War II. In September 1945, she became the setting for one of the most famous moments in modern history, when the Japanese instrument of surrender was signed aboard her in Tokyo Bay. But that wasn't the end of her service. Missouri returned to combat during the Korean War. Decades later, she was modernized and returned to active service in the 1980s. And in 1991, her massive guns were used during Operation Desert Storm. Think about that for a moment. A battleship designed during World War II was still being used in a modern conflict nearly half a century later. That's because Missouri wasn't just one weapon. It was an integrated system. The hull provided the structure. The armor provided protection. The boilers produced energy. The turbines converted that energy into motion. The shafts and propellers moved the ship. The fire control system turned information into targeting solutions. The turrets turned those solutions into firepower. And the crew kept the entire machine alive. That's what makes USS Missouri so fascinating. From the outside, it's an enormous battleship. But inside, it's something much more complicated. It's a floating power plant, a weapons system, a command center, a machine shop, a city, and one of the most remarkable examples of industrial engineering ever put to sea. This is what's inside USS Missouri, America's last battleship. If you'd like to go inside more of the technologies shaping aerospace and defense, subscribe to Brothers in Aerospace and Defense. And let us know what system you'd like to explore next.